Hello everyone, my name is Artem Boytsov and I'm a software engineer at Factual. Today I'm going to introduce an open source tool called Drake. We at Factual work with data quite a bit. We are a data company. We get data from different sources, we clean it, we massage the data, we join it with each other, we run machine learning algorithms on it, some clustering algorithms too. So as you can imagine, our data workflow tends to get quite complicated and they have a lot of steps. Drake is our attempt to address some of those issues that we ran into, and we hope other data scientists and other data engineers would find the tool as useful as we did. So I have a window here with my presentation and a couple of terminal windows open. I will give a short explanation about what Drake is and why we built it, and then I'll give a real-time demonstration about what it is like to work with Drake. We'll go over some basic concepts as well as some advanced ones, and then I'll talk about what else is being in development. So let me maximize this window for the time being and give you some background info. Drake is a data workflow management tool. But what is a data workflow? It can look something like this. You download some data from some source, it's in the wrong format, so you convert it into JSON. There are some bad entries, you get rid of them, then you make some other changes in the data, then you copy it to HDFS, and you notice that you haven't even started doing anything yet, and you already have 5 steps. So this could get annoying quite fast and can get out of hand. So we looked at this problem and other problems, tried to identify what are the most painful things that we had to experience. And we identified several. Being able to reproduce commands and beam actions with data is quite important. The locations of the files tend to get very fuzzy when you work with several engineers. New versions of the file are created, they're tossed around, emails are being sent. Hey, I created this new file in this directory, you should pick it up. So it can get very messy and a lot of errors can be introduced along the way. So one alternative is to build a process-heavy environment where any change is reflected in some documentation on the wiki, where everything is stored in the locations of the files. We thought an automated tool would be a much better approach. And then finally, when you work with the data and you're creating your workflow, you oftentimes work on the code as well and make changes to particular steps. So once you did that, the step has to be rebuilt as well as everything it depends on. But what it is exactly, sometimes it's hard to figure out in a very complicated workflow. In production, a tool like that can also be very handy. There are several issues that anybody who babysat a decently complicated workflow system knows tend to be problematic. We need to have retries and resume after failure. There's status, logs collection, email notifications, automatic backups, lots of these different features that any workflow in the company could benefit from if we all used one single tool that implements them all. So we figured we need something like Make for Data. We looked at the existing solutions that are mostly designed to build software from source code, such as Make and Rake and others, and we found that they lack some features, they lack something that we needed, and they don't give you as much control over the execution as we wanted. So we decided to build our own. Based on pretty much the same idea, the workflow is defined as a number of steps with inputs and outputs, which in turn creates a dependency graph managed by this tool. And that allows to organize the data project around one single file, just like a software project on the source code level is organized around a make file or a project file. And so that any engineer on the project could look up where the files are, reproduce any steps, or modify the workflow. So we came up with Drake, and the main design considerations were that we wanted the tool to be as flexible as possible. So it's a command line tool that can run anything as a child process. We wanted it to be smart enough to be able to predict what steps will be built, and we wanted to give the users precise control over execution, because this was often the most frustrating part, to execute exactly the subset of the workflow that you're working on or debugging. But most importantly, we wanted the tool to be very easy to use. With the reason behind it is that if the tool is not as easy or even the same to use as to write a bash script, a shell script to run your commands, then this is what the users are going to do. And when this shell script is grown to be complicated enough so that it's hard to handle, it might have already been too late. So we wanted the user to start using Drake from the very beginning. Let me give you a little demonstration. So imagine we have a couple of input files. Let's say we have a list of people with the last name first, first name second, and a phone number in a comma-separated file. And we also have a list of skills those people can have, with the name of the person in a slightly different format, first name space, last name, and the skills that this person has. This is of course a very simplistic example. In real life this could be huge data sets, and the process, the steps, can be expensive MapReduces. But it's good for demonstration purposes. So we notice that the skills is kind of dirty. We'll need to remove that. So let's write a very simple data workflow that joins these two files together and create one file with the person, phone number, and the skill set. First of all, we'll have to remove some bad entries from the skills file. I'm opening a workflow file named workflow.d. This is the default workflow file that Drake will look for, and of course it can be changed from the command line. So let me type the first step. Skills filtered as an output, skills as an input, and the command, an indented shell command. We filter out every record that contains symbols bad from input to output. So this is it. We just created the first step. So here we specify one or more output files, we specify one or more input files, and what Drake does is it puts this information into environment variables. The number of inputs, input 1, input 2, and then it runs this command as a child process. A very simple concept. So now we run Drake. It tells us what it's going to do, which can be suppressed with the command line flag. It also tells us why it's going to do this. In this case, it's because the output, which is this file, is just completely missing. Let's run it. We've done that. Let's make sure that we have what we want. Yes, so all the bad records were removed from this file. Now we need to take care of people, and we'll have to do two things. We'll have to first convert the name into the format that we desire, which is the first name, space, last name, and then we'll have to sort it, because this is required for join. The skills file is already sorted, but the person file is not. So this means we'll need to create two additional steps. Let me edit our workflow file. Let's first take care of the full name. I'm using awk for that. Specify the So let me print the first name first, space, the last name then, the separator, the phone number. Input redirected to output. This is the implementation of the first step. The implementation of the second step is even simpler than this. You just sort it by name. Let me save the workflow, and I run Drake again. So now it offers me to run these two steps. The first step doesn't need to be run because all the files are up to date. Let me confirm that. Great. Now if I run Drake again, it says that there's nothing to do because everything is up to date. Let's take a look at people sorted. Perfect. This is exactly what we wanted. So now what we need is to just merge them together. And this creates a step that has two input files: the filtered set of skills and the sorted set of people. Simple join, specify the field separator, inputs to output. So this variable inputs contains all the input files given in a space separated variable. Let me also print something just for the debugging purposes and also to demonstrate what environment variables Drake sets up. Let me save the workflow and then run Drake again. It only offers to build one target because everything else is up to date. Let me confirm that. Here's a debugging output, number of inputs 2. And this is the variable that contains all inputs, not just the first one. And as you can see, Drake fully qualifies the file name with the absolute path. Let's take a look at the output. Great, this is exactly what we wanted to do. So that's all our workflow, and we could have put it as a linear bash script, but now we have so much more flexibility, and this is what I'm going to show you next. I would like to show you also that Drake saves all the standard error and standard output of the child process into a special directory. It creates a directory for each step, and this is the last step, for example. The name is based off the name of the absolute output file. So let's change into that. So if we cat this file, this is our debugging input. And Drake also saves all the variables that were given to the child process, just for the debugging sake. Okay, so what we did is we created a very simple workflow that looks something like this. Skills filtered, there are two steps here, and then the join. What makes Drake very useful is how much control over execution you have. So right now there would be nothing to do. If you invalidate some file, if you touch it and change its timestamp, as any make-like system, it will calculate what else needed to be done. And notice that it will do people file name because it's because the file is not as fresh as it should be, it's out of date, but the other targets will be built because they are projected to build. So Drake doesn't know yet that it will need to build this, but it thinks that it will. So if we do this, okay, all of them are built, I run Drake again, there's nothing to do. But also what I can do is I can force the rebuild of everything. ... is a target that matches all existing steps, and plus means forcibly rebuild the targets. So you see that it shows that it will build everything in the forced mode. You can also specify only one target to be rebuilt. Let's say we want to build this particular steps. So in forced mode, I want to specify that only this target should be built, and for this I use the equal symbol. only one target. You can also do exclusions. For example, I want to build everything except this one particular target, which is, let's say, people full name. So you see that all the targets are listed except this one. A very common scenario is when you change something in one of the steps, and as a result you want to rebuild these steps and everything that depends on it. So let's say that we change something here in this command. I won't really change it, but let's say we did. So this means that we need to rebuild this particular step and everything that depends on it, directly or indirectly. So for that, Drake has a what we called a downtree mode. And it's turned on by using a caret symbol. So this command will forcibly rebuild target people full name and everything that depends on it. As you see, people full name, sorted, output. And the reason we chose caret symbol is because it reminded us of a little tree. So this tree with the target on top and everything that depends on it kind of looks the same. So this is why we use it. So we built a very simple workflow, and I demonstrated all the flexibility of fine-grained control over what exactly will be executed. Now, you might say that this workflow is very simple and you don't need a tool sophisticated like Drake to be able to handle that. But this is an example of a real-life workflow on one of our data projects. It's a dependency graph created based on the dworkflow file by using GraphViz by one of our software engineers. And as you can see, it's not easy to manage at all. We have targets that have multiple outputs, targets that have multiple inputs, and it's getting quite complicated. So managing it without a tool like D can be a real nightmare. Unless, of course, all the steps here are trivial and rerunning all the workflow has no cost whatsoever. Returning to our workflow, the standard syntax of Drake is a list of target selection expression, which can be one of several. And each target selection is the name of the output file, let's say people sorted, and, for example, skills filtered, and one of several modifiers. So, for example, this modifier says that I don't care about any dependencies, just build this target and nothing else. This would say, I don't care about timestamps as well, please build it regardless of whether it's up to date or not. If I remove this, Drake would still say there's nothing to do because all the targets are up to date. And not only several targets can be specified, but you can use regular expressions as well. For example, this would build everything that contains the word people, every step that has at least one output that contains the word people, which would in our case match these two steps. And you can also use tags, and this is my next topic. So imagine for a second that you would need to run some statistics on some of the outputs in our workflow. Let's say something very simple, like calculate the number of lines and output it on the console. In real life, of course, it would get more complicated. But you need to define another step. It doesn't have any output because it doesn't create any files, but it does has an input, which is our final result. And let's do just something silly like output the number of lines. So okay, so this is fine, but how do you invoke such a step? And the answer is to use a tag. So tags are special names prepended by %, and they can be used to invoke specific steps. Let's do the same thing for people sorted. And we just modified our workflow and created two little branches like this. This is just a typo. Let me fix it. So it prints the number of lines. Or we can specify both of them. So this file is not up to date because we tinkered with it last time. So let's build it first. And I will demonstrate you what I wanted to. So this would just match two steps. Tags are first-class citizens in D, meaning that you can do anything that you do with output file names with tags. And for example, you can use regular expressions. This would match all the targets that have tags that contain the word stats. Or you can also do forced mode. So since I reevaluate this target in the forced mode, it means that this target has to be built from scratch, and everything that it depends on will be rebuilt. So it means all of these targets will be rebuilt, and then the stats output will be rebuilt. Or you can also use downtree mode or exclusion or anything like that. Also, you can specify multiple tags, and several different steps can share the same tag. For example, I could create a tag named oldStats and give it to every step that generates statistics. And then I don't have to use regular expressions, I can just refer to this tag directly. This can be very convenient because you can give specific tags to certain subsets of your overall workflow that can be easily invoked. Another cool thing about tags is tags can depend upon each other, which allows you to create dependencies not through input and output files, but through tags. For example, tag B depends on tag A. This step doesn't even have any input or output files. Tag C depends on tag B, and this is, let's say, step 2. And then tag D depends on tag C. This is, let's say, step 3. Now if I run it in the forced mode, if I run evaluation of D in the forced mode, it will also pull together first step and second step and the third step. 1, 2, 3. And the reason I have to run in the forced mode is because there is no input and output files, and there are no such thing as a timestamp dependency resolution, so it doesn't even know what to do. By default, it would not run it at all. And of course, you can do all sorts of stuff that we discussed before. For example, you can exclude the previous step, the middle step, or you can run, let's say, only a specific target, like only the second step, and you can use all the variety of target selection mechanisms that we covered before. Now let's imagine that I want to do a little experiment. Let me remove this and this and this. And the experiment is, I want to make some change in people files, for example. I want to replace the dashes in the phone numbers to something else, like to equal signs or something equally silly, but this is for demonstration purposes only. So I will change this command to replace all the dashes with equal signs in the field 3, which is the phone number, and I save the workflow. Now, if I just rerun everything, then I will overwrite the existing files. What if I want to have some sort of experimental result and see if I like it? So this is where data branching comes in. So what I can do is I can run my current command in a specific branch, And because I changed this file and I changed this step, what I'll have to do is I'll have to take Drake, tell Drake to force rebuild this step in downtree mode, meaning this step and everything that depends on it, because the timestamp of the existing files are still up to date. Forced mode, downtree, people, full name. Yes. And now, because I specified a branch, that every file that is created as a result of this command will be given a suffix, and it will be created in this branch. So people.fullname-exp used the original file, people, as its input. But then after that, everything below that used the branch version as its input. And as a result, we created kind of parallel thing, and finally the output, which is a join, used the branch version of people sorted, but the regular version of skills filtered, because it didn't change in this branch. So if we take a look at the output now, we'll see that this change that we made propagated all the way over here. And now I may want to abandon this branch completely, and then all I have to do is just delete all the files with this suffix, or I can merge the branch back into the trunk by using merge branch merge option. I give the name of the branch, and then I give what I want to merge, and by default that would apply to all files. I apologize, that's merge branch, not branch merge. And by default it would apply to all files, and Drake will warn us that it will remove this file to the trunk, this file to the trunk, and this file to the trunk. But I can also use target selection to specify what exactly I want to move. Maybe just this guy. And then everything else. Everything. Just two left. And now the output is the same version that we created, and if I just run Drake, it won't tell there's nothing to do because all the files are up to date, and every output has a fresher date stamp than the input. Now we covered quite a lot. We covered most of basic functionality, target selection, dependency resolution, branching, tags, and I would like to go over some features that are not as important, but still pretty cool. So first of all, Drake does support HDFS. What it means is that Drake can look at HDFS files and compare the timestamps to local files or to other HDFS files and resolve dependency this way. And then also it supports partial files that Hadoop generates. So when you give Drake a directory, a MapReduce output, for example, that it will look at all the partial files and make sure that the youngest file in the output directory is still fresher than the oldest file in the input directory. The other way around, I'm sorry. Let me demonstrate this. Let's see that the output is not the final destination. We want the output to copy into HDFS, where some further processing will take place. So what I want to do is I want to create another step, and this time my output is on the HDFS file system. HDFS is a file system prefix. As you might have guessed, I didn't need to use this prefix because the default prefix is a local file system. And then I'll need to copy it using Hadoop binary. I copy input into output. Now because Hadoop doesn't really have override option, I will also have to remove the old output and suppress any errors if I have any. So now I saved the workflow and let me run it. Everything in this workflow were up to date except this new step that we just added. Confirm. And now this file, sorry, I made a little mistake. This is wrong. This is right. This is the count command for removing. Let me run it again. copying to HDFS. Done. Now if I run it again, it will say that everything is up to date because the HDFS file is younger. So now let me touch one of the inputs that we have. Let's say skills. It will result in generating new skills filtered, new output, and of course copying the output to HDFS. Which is very nice because if one of your steps is local and another is an HDFS, then it would be nice some tool to handle exactly if the copy has to take place or not. So the other thing that I would like to mention is that targets doesn't have to have inputs or outputs. There could be a target that don't have any input. For example, if you want to download something from the web or from any other source for that reason, then this target doesn't have any input. Let's say wget, save it into the output file, www.google.com, save it. So now if I run Drake and I say that I want to build download, the reason is missing output because download file does not exist yet. I confirm it, and in the file download we have the home page of Google. Another useful feature of Drake that I'd like to touch upon is methods. Methods is a simple way you can reuse some of the code in your workflow. For example, what if output is not the only file that we need to copy to HDFS? So what we can do instead is we can create a method that runs exactly these commands and name it copy to HDFS. Now this creates a method with the same implementation that we used before, and now to invoke this method, all we need to do is to specify the step without any body and give it an option, method name. We haven't used options before because we didn't have to, but any step after output file and input file can have an optional section in square brackets that have several name value pairs, and in this case we use the method option and invoke it this way. Now let's copy something else to HDFS. Let's say people. Sorry, people sorted. Now if I run Drake, output doesn't have to be copied because it's still up to date from our earlier experimenting, but this one does. And now if I made some changes to this code, I want to be able to easily rerun all the steps that use this method as implementation. And this is possible. You say rerun all the targets and them only without any dependencies that use method copy to HDFS. We need to use quotes now because parentheses are special symbols for bash. And you see that the steps are listed, the reason is given, because this is forced via method. And of course we can also suppress it by using command line switch. And then finally, I would like to touch on the notion of protocols. So far, we didn't have to use anything other than shell, but shell is not the only way to execute commands. Drake supports several protocols, and a protocol is basically an implementation of an interpreter, a way to execute commands. In the shell case, it creates a temporary file and runs the current shell on it. In a Python case or Ruby case, it might run the Python interpreter. There could be other protocols such as a pig query, then it would run a pig query. So it all depends on the implementation of protocols, of the of the protocol. And currently, the implemented protocols are Shell, Python, Ruby, and some more complicated closure-related ones. We also plan to implement a Cascalog protocol, but generally, you can add pretty much anything. So let me show you some Python code, let's say, and we'll do some simple statistics on the output, just as we did with WC. Give it a tag name, give it an input file, hello from Python, and let's print the number of lines in the file. So first of all, we need to specify that we want to use the Python protocol. There's a special option for that. So we can do it this way. But protocol is actually the default option name, so you don't even have to specify the option name here, so we can just leave it like this. It's a little bit more readable. Also notice that the way that I refer to the variables is a little different. I can't just use the syntax we use for shell, because this is shell's syntax to refer, this is bash's syntax to refer to environment variables. I can of course get to environment variables from Python pretty easily, but what this does is this is a thing specific to D, and this is string substitution. Before giving this command lines to Python, D will substitute this string to the actual name of the input file. This is why I have to use quotes here, because D doesn't know what the context of this, and we'll just substitute from here to here. So let me save it and specify it. Hello from Python 3. Great. This is exactly how I want it to work. So we've covered quite a lot of stuff. We've covered some basic features, some advanced features. I gave you a demonstration of how it works. Now let me go quickly over some features that are still in development. They are specified in the design doc that we released, but they're still not ready yet. We do envision Drake to have a nice status console, so when you run a data workflow, it would listen on some port, show you the list of tasks, links to their existing logs, the dependency graph of the current workflow, color-coded with what's done and what's next. Also, an important feature is management of old versions of the files. Because if you have a tool like that that is given the information about inputs and outputs, then you can easily implement some very powerful features. For example, you could specify that you want it to keep the last 6 version of the file, and then you can revert easily by providing the time in the past, the moment that you want to revert to. Or you can specify that you want to keep all the old versions for the last 3 months, or maybe even until the backup exceeds 100 megabytes. So this could be a very convenient automated backup and revert mechanism. We also want to implement retry, similar notifications, and other small things. One particular thing that you can do once you specify your workflow in this way is you can parallelize processes, because D knows that in this particular example, process 1 and process 2 are independent. So you can run at the same time. If these are remote processes or map producers on a Hadoop cluster or 2 different clusters, this is what you would want to do anyway. And also maybe one of those processes is I/O heavy and another is CPU heavy, or you have a multi-core machine and single thread processes or something like that. But anyway, Drake can know in what cases it can be parallelized and launch them at the same time. So of course this is an open source project. We do want to implement all these features, but your contribution is also welcome. If you find this tool to be useful, we would be really happy to work with you and to review the code and to hear from you. So one last thing, that came up several times is, why did we implement this as a command line tool versus a library? A library obviously is very flexible because you can run native code instead of being limited by running binaries and shell commands. So our approach to that is, everything that you see here, the syntax of this is just one of the possible front ends to D. Other front ends can be implemented. For example, one can reuse the core D library and write a closure domain specific language that would use something like this, would specify the steps in similar way, and given closure functions that would be run instead of running commands and child processes. And then you can run it like this, having reused the target selection mechanism that we talked about previously. So we don't think that it's an either or, and we're looking forward to people creating more libraries in their favorite programming language. Everything that runs under JVM, I suppose, would be compatible with Drake's core library. So that's it. Thank you very much for listening, and we hope that you will find it useful. Please do not hesitate to contact us with feedback, bug reports, code contributions, or questions. We're looking forward to seeing this tool being used in other places than Factual, and we hope that you'll find it of some value as we did. Thank you. Bye-bye.